Hello guys, so in this video we are going to say this particular problem, maximize the topmost element after k moves. So what this problem says is, you are given a zero index integer array nums representing the contents of a pile where nums 0 is the topmost element of a pile. So basically an array is given and here all the elements are there. This first element is the topmost element of the pile. What we can do here is, in one move you can perform either of the following operation. Either you can remove the first element of the pile, or suppose you have removed two till now, so a and b are removed. Now the pile suppose is remaining is C, D, E, and F. Okay. Now what we can do is, you can either remove the first element from the pile, or you can take any element from the removed elements and put it back to the pile. So these two operations you can do, and you are given an integer k which denotes the total number of moves to be made. And after k operations, you have to find out like what is the maximum value that you can put in the front of the pile, that is the top of the pile. If you see example here, 522406. So first 5 is removed, then 2 is removed, then 2 is removed. So 3 steps gone. Now one move is only left. So we have added 5 to the front of the pile, and this is our answer. Like this 5 will be the top of the pile, and this is the maximum that we can get by using k is equals to 4 moves. So what is the intuition behind it? Let's see. Let me erase this and see. So if you see here, value of k in the constraint is given that k can go up till 10 power 9 and n can go up till 10 power 5. So basically we have here three cases. k is uh, k is greater than n for the timing. Okay, so let's suppose k is greater than n. Now before moving on to this, you have to understand that once an array is given and k is given, so the elements that can be affected will depend upon the value of k. So if suppose k is something, k is something, okay, don't consider this for now. This is just an I'll handle this case, but before that let's understand this. So if this is k, so the number of elements that can be affected will be at max the first k elements. Okay, before we can move make only k moves, right? And every time if we remove, then we can reach until this k, and that's only the number of elements that we can affect, not more than that. So keep this in mind. So let's see. So what I'm saying here is, yeah, let's take the case where k is less than k is greater than n. So when k is greater than n, what we can do is, in the elements that we have here, we can take out all the elements. Okay, now let's see. If we take out all the elements, what will happen? We can take out all the elements, okay, and put it in a queue, priority queue, suppose. Okay, so suppose we have taken all the elements and every element is present here. Now, after we have taken all the elements, we have already done k moves. So now the value of k remaining is k is equals to k minus n. Now, after removing this or after doing this, this k that we have can be either even or it can be either odd. Why I'm taking even or odd? Let's see. So when you have taken everything removed from the pile, so now the pile that we have here is empty. Now, since in this code, here we have uh, all the numbers. So there can be a min, there can be a max. Okay, n will also be like always be greater than equals to 2, because for 1 we have handled the case. I'll show you in the code. So for the timing, n will be greater than equals to 2. So now what we have here is, if suppose k is odd. Okay, so when k is odd, so what we can do is, this pile that we have, in the pile we can first put min and then we can put max. Okay, so suppose sorry, not this. Suppose in the pile we have the k is odd. Okay, so here we'll put max. So suppose for odd, suppose for 1, we are saying. Okay, so if k is 1, after doing this k minus 1, so what we can do is, suppose k is odd, and let the minimum odd be 1. So what we can do, we can simply take the maximum out of all the elements that we have, since we have all the elements taken out from this pile. So out of all the elements, we will take the max and put it here. So this will be our move, that is k is equals to 1, that is left after doing k minus 1. So in 1 we can put max. Suppose if k is odd and it is equals to 3, so what we will do now is, we will take the minimum, put it here. Now it will become max and it will become min. Okay, two steps. Now one more step is remaining because the total is three steps. What we will do? We will simply remove min again. So max will be there, min will be removed. Suppose 5 is there. So what we will do? We have to go see this is for 1, this is the 3. So if the difference is 2, what we are doing, we are simply putting min and then we are taking min out. If suppose we have for 5, we will again do this, put min and take out min. So what I mean to say here is, if k remains odd after doing k minus n, then we can simply take the maximum out of all these elements and then we can return it. Okay. Now one more thing. Suppose k is even. When k is even, then what we can do here is, we will put, suppose even is 2. What we can do is, we can put minimum here and then we will put maximum. Okay, so in that case, what is the top of the file? The maximum element that is present in the whole, or like all the elements. Suppose we have for 4. So what 4 we can do? We can simply take out max and then we can simply put max back. Okay, we take out max outside and put max back. So after 2, here we have 4. Again, the answer is max. Suppose for 6, what we can do? We can again take out max and then put max back. Again for 6, max is the element. So basically what I mean to say is, when k is greater than n, then whatever be the value of k, whether it is odd or whether it is even, it is always going to return the maximum value, or that will be our answer, the top of the like the pile. Okay, got my point, right? So when we have this k greater than n, in that case we will already return the maximum of the elements. So let's see in the code first. So if you see here, if k is greater, see, this is for n is equals to 1 we have handled. If n is equals to 1 and k is even, then we'll simply return the value, else we will return minus 1. I'll show you at the end why this is the case, but let's see here. When k is greater than n, what we are doing, we are simply taking out the maximum and returning it. So this is the case where we handle k is greater than 1. Now let's handle the case where k is less than n. Okay, now when the case where k is less than, let me remove everything. Yeah, let's see. So when k is less than n, okay, when k is less than n, so the elements will be like this. Okay, so what we can do, if we think a bit here, what we can affect at most k elements. So okay, and then what we have to do is, we have to find out the like most maximum value. Okay, so if we take out all the k elements, then we are exhausting our k moves. Okay, so we cannot choose the maximum value. If we exhaust the k, the whatever is remaining after the k, that will be our max value. So we are not able to choose the max value. Okay, so for choosing that max value, what we are going to do is, we are going a step less. What we are going to do is, we are going to take k minus 1 of these value out of these. Okay, not k minus 1. So we are still remaining with one move. So after doing k n minus 1, suppose this is the case, we have taken the k minus 1 elements. So these three elements are now we have in the bucket. Okay, 1 2 3, and now these three elements are remaining here, and we are remaining with one more step, because we have already done k minus 1 step and taken out all the elements till k minus 1, so that we can get we can take more like more number of elements, and we can take out the maximum out of that. Okay, and put it back to the pile, so that we can get our answer. So now this one step that we are remaining, so what we can do is, we can check the maximum that is here. We can if suppose this is max 1. Okay, max from this removed one is max 1, max removed. Okay, max removed, and then one step is remaining here. So in this one step, what we can do, we can take the maximum from this one, put it in the front of the pile, or this last one we can remove this one, put it in the pile, and then this will be our top of the pile. Got my point, right? So this last step remaining, what we can do, we can see the maximum present here, and after removing this, what is the maximum value that we have here? This after taking this one step, what will be the maximum value that is here, the value that is here? So out of these two, which one will be maximum? That will be our answer. So like this is basically what the point, why we are going up till k minus 1, so that we are remaining with one more step, and to conclude like which one of the maximum, either from this pile or this one. Got my point, right? Okay, let's see. So suppose k is equals to 4 here. So it's 0, 1, 2, 3, 4. So what we have done, we have gone from 0 till 3. Okay, so we have taken out these three. We have one step more remaining. Okay, taken out three, one step more remaining. So one step what will be? We'll be either be removing this one. Okay, either removing this one or taking the maximum here and taking that answer, this one as a maximum. So let's see the code here first. So if you see here, what we are doing the same thing. We are starting from 0 and going up till k minus 1. So basically total k minus 1 steps. Okay. So for this k minus steps, we are finding out the maximum in that particular removed list. And then what we are doing is we are checking the last one. So last one, what we are doing is in last one, we can remove either the one that we have here. Either we can remove this one. If we remove this one, this is the kth one, right? This is the fourth one. K is equals to 4. So this is the fourth one, which is this. So in this or the maximum of this, which one is maximum? So that we are selecting here. So once we select that, we can simply return the maximum here, and that will be our answer. Okay. Now the case where k is equals to n. Now let's see. Case okay, let me check the pen. K is equals to n. When k is equals to n, what we have is, let's see. Yeah. Okay. Suppose this is 1, 2, 3, 4, 5, 6. So k is equals to 6. So when k is equals to 6, what we can do here is, let's see clearly. As we have seen earlier, we can take 5 elements here. Okay. So in 5 moves, what we can do is we can fill up our removed pile 1, 2, 3, 4, 5, and 1 is remaining here. Now in the sixth move, what we can do? In the sixth move, we cannot remove this one. Okay. Because if we remove this one, then we do not know what is the maximum of the pile. Okay, if we remove this one, then the pile that will be present here will be empty, and for empty we are like the -1 is the topmost element. So we need not to do that. So what we are going to do is we are going to take the maximum out of this pile and put it in the front of it, because if we see the constraint, nums of I is always greater than equals to 0. Okay, so it means that if k is equals to 6 and k is equals to n, in that case k minus 1 elements we have taken, the last one we cannot remove, because if we remove the last one, then the top of the pile will be -1. Else what otherwise what we can do, we can take any one of this and we'll put it here. So any number we take from here will be greater than -1, because nums I is greater than 0. This is the constraint that is given. So what we are going to do from this pile, that is k minus 1 elements that we have removed from here, we are simply going to pick the maximum one, and that we are going to put it in the front of the pile, and that will be our answer. Basically the maximum one out of this. So that is the same thing we have done here. What we have done, from 0 till k minus 1 we are going, and we are like taking out the maximum and then returning it. That's it, nothing else. Okay, so I hope you would have understood this particular problem. So let me try to submit this. So this is it. When n is equals to 1, so basically what I mean when n is equals to 1 is, suppose there is only one element. Okay, so what you can do is you have the pile where you have only one element. Suppose this element is there. When n is equals to odd, okay, so what we have to do is, suppose k is odd. So suppose k is equals to 1. So in one step, what we have, we do not have any removed part. Okay, this removed bucket and this pile. So initially there is one here. So we cannot take remove from here and put it here, right? When k is equals to 1. So what we have to do, we have to take from here and put it here. So in one step, what we can do, we can put it in the removed one, and this is empty. So if k is equals to 1, then we have empty and we'll return -1. Suppose you have k is equals to 3. So what we have to do, we cannot remove from here. We already will have to remove from here and put it here. So we have put it here for the second step. Now in the third step, this removed is nothing, and here only one is remaining. So in the third step again, this will have to be moved to here because nothing is there. So this is basically what I mean is, if in the third step this pile will be empty again. So it means that whenever k is odd, we are returning -1, and whenever it is even, the element is actually in the pile itself. Okay, so that is why when n is equals to 1, k percentiles 2 is equals to 0, that is even, we are returning nums of 0, else we are returning minus 1. So if you see the code here, that is what we are doing. If n is equals to 1, k is percentile is 0, then we are returning the number, otherwise we are returning minus 1. So that's it. This is the program. Let me try to submit it. So if you see here, so this is our answer. It is faster than 100% of the time and space as well. Okay, so I hope that you guys have liked this video. So if you did, like, share and comment to this video. Thank you.